Solving quadratic equations using the quadratic formula. Number one, if a quadratic equation is in standard form, where you have the quadratic term, linear term, and then the constant term, decreasing degree order, the exponents are decreasing, set equal to 0, then there may be two unique solutions given by the quadratic formula, which is x equals negative b, or opposite of b, plus or minus the principal square root of b squared minus 4 times a times c, all divided by 2 times a. The radicand, b squared minus 4ac, is called the discriminant, or the radicand. B squared minus 4ac is the radicand, or discriminant. And later you will study how it gives you the types of roots or types of solutions, whether they're real numbers or pairs of complex conjugates. Number two, when using the quadratic formula, the first step is to write the quadratic equation in standard form, which again means the exponents are decreasing and constant is in the third position left to right and set equal to 0. There also would be only addition and no subtraction. And if you had subtraction, by the definition of subtraction, if there's subtraction between terms, you can rewrite that as addition of the first term plus the opposite of the second term. Number three, write the quadratic equation in standard form and then identify the values of a, b, and c. Part A, do not solve, but identify a, b, and c. So if we rewrite the equation in decreasing degree order, with negative 4 becoming plus 4 equals 0, then the leading coefficient would be a, negative 2, b would be positive 1, and the constant is 4. Part B, the quadratic term is negative 3x squared, and if we subtract 8 from both sides, then we'll have 2 subtract 8 is minus 6, set equal to 0. So there's no linear term, and thus we would write a placeholder, 0 times x minus 6 equals 0. So the leading coefficient is negative 3, b is 0, and the constant c is negative 6. In part C, there's no constant. It's could be represented by 0. So we have 3x squared, subtracting 6x, and the constant is understood to be 0, set equal to 0. So a is the leading coefficient, b in standard form, there's addition only, so b would be negative 6, and the constant is 0. Number 4, solve the quadratic equation. Step 1, write the equation in standard form, only addition, no subtraction. So if we did that technical step and wrote only addition, minus 2n would become plus negative 2 times n plus negative 3 equals 0. So a, positive 8, b, negative 2, and c, negative 3. Step 2, substitute the values of a, b, and c into the quadratic formula. So we'd have x equals negative b is negative 2 plus or minus the principal square root b squared in parentheses is negative 2 squared minus 4 times A is 8 times C, negative 3, all divided by 2 times A is 2 times 8. Simplify. So we have x equals positive 2 plus or minus the principal square root of 4 plus 4 times 8, 32 times 3, 96, all divided by 16. Part D says, what is the value of the radicand? It is 100. So we have x equals 2 plus or minus the principal square root of 100. 100 is a perfect square, divided by 16. Simplify. So x equals 2 plus or minus 10 divided by 16. So we have either x equals 2 plus 10, which is 12 divided by 16, or x equals 2 subtract 10 divided by 16. So that's 12 sixteenths, which can be simplified, or negative 8 sixteenths, which can be simplified. So if we divide by 4, we have 3/4, or x equals negative 1/2. Now it would be time consuming to substitute each solution and check, but what we can do is the sum of the roots check and verify that if you add the roots together, verify that the sum is negative b divided by a. So let's add 3/4 plus negative 1/2. And since b is negative 2, that's going to be negative 2 divided by a, which is 8. So is this true or false? Well, on the left side, we have common denominator of 4. So let's go 3/4 minus 2/4. Does that equal positive 2/8? So 1/4 does equal 2/8 simplified is 1/4. We have a true statement. So the solutions are negative 1/2 or positive 3/4. Number 5 is a quadratic equation, and the instruction is only to solve. It doesn't say by what method, by factoring, by completing the square or the quadratic formula, so you would have a choice. But maybe you can quickly see that this is not factorable, right? Because it would be greatest common factor of all three terms is 1. And the constant one, its only pair of factors is 1 times 1, and there's going to be no way to get a middle term of 4q. So the factoring is not going to work. Also, you can do the discriminant test for factorability, which says if we take from the quadratic formula b squared minus 4 times a times c, and from standard form replace b with negative 4, and substitute for a positive 2 and c is 1, we get 16 minus 8, which is not a perfect square. So if the discriminant value is not a perfect square, that means the trinomial cannot be factored. So the general rule is if the discriminant is a perfect square, like 0 or 1 or 4, etc., if true, then the trinomial is factorable if you wanted to solve by factoring. Otherwise, not. If you do not get a perfect square, then the trinomial cannot be factored, and you can't solve by that method, but you can always go to the quadratic formula. So by the quadratic formula, we can solve to find the two roots. We have not x equals, but q is our variable, equals negative b. So it's negative 4 plus or minus the principal square root of the discriminant, b squared minus 4ac, which we already computed, is 8, all divided by 2 times a, 2 times 2. So that's positive 4 plus or minus. 8 contains 4 as a perfect square that we can square root, divided by 4. Do not divide and cancel 4 here. That would be not a correct way to divide and cancel. You can divide and cancel common factors between the numerator and denominator, but not a term which is separated by addition or subtraction. So we have the principal square root of 4 is 2, and then a 2 inside of the square root. Again, we cannot divide and cancel the 4's, but we can factor out the greatest common factor of the numerator terms is a 2. 2 times 2 is 4, and 2 distributes to the square root of 2, all divided by 4. Now, the 2 outside the parentheses is a factor. Factors can be divided and canceled. So 2 divides 2 one time, 2 divides 4 twice. So our two real number irrational roots are 2 plus or minus square root of 2, all divided by 2. Probably would not change this, but it's also that you can divide the denominator into each term of the numerator is the equivalent.